Okay, welcome to the video on part 1 analysis of the concentration dilution exploration. So one thing I forgot to mention in part 1 when I went through the procedure is filling out this section of the data table where you're filling out the chemical formula, molar mass of each of the different salts that you're using. So I did the first one for you. The chemical formula you can get from the name. So this name is called cobalt 2 nitrate. So what you would do is you look on the periodic table. Cobalt is CO. It has a, because of the Roman numerals in parentheses there, that tells you it has a +2 charge. Nitrate is a polyatomic ion, which has a formula NO3 minus. Because nitrate has a -1 charge and the cobalt has a +2 charge, you know you would need 2 nitrates. And so you would write the chemical formula like this. And I'm going to go ahead and just put these in as subscripts just to make it clearer, but you don't have to. So that's the chemical formula. The other place you can get the chemical formula is from the lab itself. So for example, when you select cobalt 2 nitrate, you will notice the chemical formula will be written on the salt shaker. Okay? When you select cobalt 2 chloride, you notice that it's here, COCl2. So I'm going to take that formula, and that's my chemical formula. And then the last one for potassium dichromate, the same sort of thing. When you click on it, it will give you the formula K2Cr2O7. And so that's what's written here. All right, the last part to this is getting the molar mass. Now, remember, the molar mass comes from the periodic table. So we went over this in class, and I'll go over how to calculate the molar mass of cobalt nitrate. So to get the molar mass, remember you go to the periodic table and you look at the average atomic masses for each element in your chemical formula. So I have one cobalt here, and each cobalt has an average atomic mass of 58.93. I have 2 nitrogens in cobalt nitrate. I know that because there's a subscript of 2 outside of the parentheses. So that tells me I have 2 nitrogens. So then it will be 2 times the average atomic mass of nitrogen. And then I'm going to add finally, I have 6 oxygens. Each one has an average atomic mass of 16. So this is what I do, is I just sort of basically add up the masses of all the elements in the chemical formula using the periodic table. So that's how we get the average atomic mass. And that's how you would get this number here for cobalt nitrate. You do the same thing for cobalt chloride. And again, I'm going to put these as subscripts just so it's easier for you all to see the formula, but in your work you don't need to. Just so you know, in order to put something as a subscript, you would highlight the text you want as a subscript, do Control, comma, and it gives you a subscript. All right, so you would get the molar masses again from the periodic table. Now we're going to move into the calculations that we need to use to get the moles of solute and the grams of solute. Okay, so now I'm going to show you how to calculate the moles and the grams or the mass of the solute using the information in the table. So there are 2 equations that you're going to use. The first equation that you're going to use is molarity, which is your concentration, is equal to moles of solute. That's the solid that dissolves in the water over liters of solution. Okay, and you're going to use this equation to solve for your moles. So that value there. This is what this is our unknown. The second equation that you're going to use is the equation for that will help you to find the mass. And that equation is moles is equal to mass over the molar mass. Okay? And so in this case, what you're going to do is you're going to use the value of moles that you got from the first equation, plug it in here, use your molar mass that you get from the periodic table, plug that in here, and you're going to solve for mass. And remember, mass, the unit for mass here is grams, so that's why it says grams of solute. You could also just say mass of solute. Okay? So that's what we're going to do. So let's go ahead and work through these problems. we're going to start with solving for the moles. So for the molarity, what you're going to plug in is whatever you have for your concentration. So in this case, I have 2.135. Again, if you were in class, I got a different number when I did that experiment. So the second time that I did it, the concentration of the solution I sort of went over was 2.135. So that's going to go in here. Now for your volume of solution, it's going to be the volume of water. Now technically, these are not the same thing. So the volume of water, which water is your solvent, is not always equal to the volume of solution, but they're usually pretty close. So we're just going to use volume of water here. So that's going to go on the bottom. Okay. And then on top, we have our unknown moles of solute. I'm just going to write moles there. All right, so how do we solve this? Remember, whenever you have a fraction next to an equal sign, you can cross multiply. So to help me with the cross multiplication, I'm going to take this whole number and put it over 1 just to make it a fraction. It just makes it a little bit easier. And now we're going to cross multiply. Now remember, when you cross multiply, you're multiplying the number in the numerator of the first fraction with the number in the denominator of the second. So these two values will get multiplied together. And it doesn't technically matter which side of the equation you put the product of that multiplication on. I'm going to put it on the left. So 2.135 times 1. That's going to go on the left side of my equal sign. Now on the right side of the equal sign, I'm going to do 1 times moles. Okay, which is just moles. So I have just solved for my moles. My moles is equal to 2.135 using cross multiplication. So when you're using cross multiplication, just a reminder, when you're solving for an unknown, it doesn't matter on which side of the equal sign you put your products. However, if you're using cross multiplication for figuring out which fraction is bigger, then it does matter. But in our case, for solving for unknowns, it doesn't matter. So we go ahead and we have our unknown from our cross multiplication. Now we're going to go and use this value in step 2. We're going to plug that in here to solve for so this number, I guess I should put it this way, the arrow this way, here we go. That number is going to go in for our moles. And our molar mass, well, that's going to come from that periodic table. It's already in the chart there. So I'm going to plug those numbers in. So now what I have is 2.135 is equal to mass, which is my unknown, over 182.95. Again, I have a fraction next to an equal sign. I can use cross multiplication to solve. So for my whole number, I put it over 1 just to make it into a fraction. Just makes my life a little bit easier. And now I'm going to go ahead and solve with cross multiplication. So in this case, it's going to be 2.135 times 182.9. 95, okay? On the right side, and then on the left side I'm going to have 1 times the mass. So my mass. Now when I do that multiplication, so if I have $2.135 times 182.95, I get this value, 390.59825. Now in this case, if I go back to my numbers here, if I look at the number of significant figures, this one has 5 sig figs, this one's 3, this one's 4. I need to use the least number of significant figures, so I'm going to cut this off at 3 sig figs. That means that when I'm cutting this off between the 0 and the 5. Okay, let me turn the light on, maybe you can see that a little bit better. Maybe not. So my value here is 3.9, 390.598, whatever. So I'm going to cut it off between the 0 and then the 0.5, so that becomes 391 when I round it up. Okay, so my mass is going to equal the product of these two things, which is 391 grams. Okay, and so I can go ahead and plug that value in here, 391 grams. Oh, and I forgot to plug in my moles. Go ahead and do that. My 2.135 moles. And once again, for significant figure's sake, I would cut this off. It's 3 sig figs, so I would cut that off, and again I would round the 3 up to a 4. So here I'm going to put in 2.14. Okay. So that is it for this video. You're going to do the same procedure for the other salts that you did, other solutions that you made. So remember, you start off by using the molarity equals mole